to our video. I'm Dave Mayo, General Manager of AGI MotorTec Incorporated. AGI is a well-established supplier of electric motors to agricultural fan manufacturers, or OEMs as we call them. In this video today, we're going to compare the energy saving potential of two different types of agricultural fan motors normally used in a 24-inch exhaust fan. The first test will be of a PSC fan motor, or permanent split capacitor as it's known, and the second test will be our electronically commutated, or EC motor, our new style. The main difference between these two half-horsepower motors is the PSC motor is an older technology capable of reasonable variable speed performance, while the EC motor is an electrically commutated, highly controllable motor with excellent variable speed performance. This becomes a very significant advantage when the motors are being operated as variable speed, which is common for many first and second stage ventilation exhaust fans used in a variety of animal housing, including poultry, swine, dairy, and others. Both motors will be tested in the same specially modified through-the-wall fan that's typically used in livestock and poultry barns. First, let me introduce you to our test fan, a 24-inch, three-bladed, through-the-wall barn exhaust fan, very common type of fan. Back here we have a specially constructed plywood extension, about 2.5 feet long by 2.5 feet square. The extension allows us to smooth out the airflow so that we can more accurately gauge the air velocity and measure the CFM per watt that we're getting from this fan.
Hi, I'm Frank Pesky from AGI MotorTec. When driving in the country, you may have spotted barns, some long, some short, with exhaust hoods sticking out the sides and rooftop chimneys. Each of these barns can have dozens of exhaust fans. Depending on outside weather and the age and density of the livestock or poultry, continuous ventilation at various rates is necessary.
So, how many chickens are in this barn?
We got 26,000 here. They're 7 days old today. And our ventilation now is running about 4,000 CFM. Versus when we started, it was half that at 2,000.
So every day the temperature will start to get lower as the chickens grow.
Yeah, we started at 93 Fahrenheit and we're down to 86 here now, and every day they'll go down another degree Fahrenheit until we get down to 70.
In addition, circulating fans are often employed higher up near the ceiling in the barns to keep air moving. The fans remove odors, heat, and humidity, and also draw in fresh outside air to ensure the optimal health and comfort of the animals. During hot weather, all fans must run continuously to keep the temperature and humidity within safe limits. In cold weather, ventilation must still be provided, but heating costs can also be added to the equation. This need to operate fans so often results in electricity costs to run fan motors as a significant yet manageable cost.
Joe, how many fans would they have in this barn?
Right now, we're using 10 exhaust fans, 3 of which we use with variable speed controllers. And at this point, we're just using one fan for the first 3 or 4 weeks, depending on the weather. And eventually, in the summertime, it's usually only around 3 or 4 weeks out of the year where we have all 10 of them running. And the other fans on variable speed are the circulating fans. We have 6 of those as well.
We first test a traditional PSC motor and then a new AGI EC electronically commutated motor. They'll both be tested at the same selected speeds under the same conditions. We'll show the highlights of the actual testing and the comparative readings of airflow, cubic feet per minute, versus watts consumption, and compare the results using CFM per watt. We'll end doing a calculation of actual energy dollars saved under given operating conditions. As mentioned earlier, the first few stages of fans are variable speed to match the required ventilation rates to the actual need for maintaining the inside air quality. Commonly, the target desired barn temperature set point is programmed into an electronic control that determines which fans are required, if they are variable speed, and what speed is necessary.
As the temperature rises or falls, the controller will vary voltage to the motor to speed the fan up or down to maintain the desired temperature and humidity. The controls used in this demonstration are also commonly used, but there is one significant difference. For PSC motors, a triac-based control is used, which varies the voltage to the motor between 0 and either 115 or 230 volts, depending on the voltage the motor is connected for. Typically, these controls employ either a temperature transducer or humidity sensor, which triggers the voltage variance to the motor. With PSC motors, full voltage will cause the motor to run at full speed. As the voltage is dropped, the fan motor slows accordingly. The way the triac control chops the electrical waveform creates issues with speed stability and does very little to save energy.
For EC motors, the same principle is involved. External temperature or humidity sensors are used to vary speed based on the control settings. However, in the case of EC, the fan control supplies the motor with a 0 to 10 volt DC signal that is connected to an internal circuit board located inside the motor. This driver circuit converts AC to DC, and because electronically commutated motors are in fact three-phase direct current permanent magnet motors, they're capable of precise speed control and constant torque with extremely high efficiency. Not only are these motors much more stable, they use significantly less energy, saving on operating costs.
Hi, we're back here again. The birds are 3 weeks old now, so we've had our minimum ventilation double 3 times now. We started at 2,000 CFM and now we're running 16,000 CFM as our minimum overnight. And we've had pretty mild weather lately. The nights haven't been too cool, so we're actually a little over 20,000 CFM now. But we're still running on just 2 fans. Right now, it's a bit warmer. We're over 72 degrees outside, and we've got 50,000 CFM running currently with 2 48-inch fans.
Are these 2 variable speed, Joe?
One fan is variable speed, and the second one that's just running on auxiliary is fixed speed.
On to the actual side-by-side tests of the PSC motor and the EC motor. Here we are testing the fan unit with the PSC motor. The handheld airflow meter shows the CFM of air the fan is producing at various fixed speeds. The panel meters show the watts being consumed.
Here she is running at full speed, H907, 1550 RPM. Here's the readings for 1190 RPM. Okay, here's H907 with the triac at 840 RPM or thereabouts. Here's the readings at 448 RPM.
Using this data, we can calculate the PSC motor's CFM per watt at various speeds. Now we perform the same test using the same fan under the same conditions, only this time using an electronically commutated motor.
"24-inch fan, 1190 RPM, EC907. 24-inch fan, 850 RPM. Here we are at the minimum program speed of 450 RPM. We're just going to go over now and see what we got for our amps and our watts. Look at that. 0.3 amps and almost no watts.
For easy comparison, here are some combined images of the meter readings for PSC and EC motors at the 4 test speeds. As you can see, using an EC motor in place of a traditional PSC motor, the operator would save large amounts on his power costs, and the results are especially dramatic in the lower end of the RPM range. Now we'll plug all the numbers into our handy energy savings calculator and demonstrate the power cost savings for both motors running full-time and half-time.
Red arrows will point out the key variables on the calculator: fan test RPM, power cost per kilowatt hour, and the input CFM per watt from our tests. The annual operating cost is calculated for each motor, and finally, the savings.
Hi, we're here again. It's 6 weeks old. We've got birds in this barn now. We're in September, but it's hot out today, about 84 degrees. We're running about 82 inside the barn with our sprinkler system as the cooling. And this is about 225,000 CFM at the moment. We're running near capacity. For any of our variable speed fans that we run 24/7, it'd be a good option to have an EC motor for that case. The payback's so quick, the power consumption's so much lower that you can easily justify it as soon as you're running that many hours.
We hope you found our video informative and enjoyable. For more information, go to our website or contact your local AGI representative. Thank you.